Alright, so this is the fourth question that we're going over. This is the second video, and so the question is, we've got a right triangle whose hypotenuse is 3 meters, square root of 3 meters long. It's revolved around one of its legs to generate a right cylinder cone. Find the radius and the height so that you have the greatest volume. And so what we have is, we have this right triangle, square root 3, and we're going to have our x and our y. Okay, the x will also be the radius of it as we revolve it around, and the y will be the height of it, which we can actually change. X will be r, and then y will be h. And so what we'll do is, we got to find our constraint for our h and y. Well, it's going to be h squared plus y plus r squared equals 3. Okay, and that's by Pythagorean theorem. A squared plus b squared equals c squared. And so what we have here is, when we revolve it around, this is our constraint and what we have. Now we want to find the greatest volume, so that means we're going to use v is equal to 1/3 pi r squared h. And as you see, we have an r squared in both of them, so why don't we just use the r squared? So what we'll do is that we'll solve for r squared, moving this to the other side, getting us r squared is equal to 3 minus h squared. And this will be plugged in to there. So we have v is equal to 1/3 pi times 3 minus h squared h. Okay. Simplifying, simplifying everything through. That gets us a. That gets us v is equal to, let's see here, it would be pi h minus pi h cubed all over 3. And now what we'll do is that, since we want to maximize, we've got to take the derivative of it. So we take the derivative of v, which will be v prime, take the derivative of pi h, which will be pi, minus the derivative of this, which would be pi h squared. And now what we're going to do is we'll solve, set it equal to 0, pi minus pi h squared, move those to the other side, getting us a pi h squared is equal to pi, h squared is equal to 1, which means that h must equal 1. Okay, so h equals 1. That would be our height. So now we got to go, okay, well, if that's our height, what's our radius? Well, our radius, we'll plug this h into there, and we'll find that our radius will be 1 squared plus r squared is equal to 3. So that means r squared is equal to 2, which means r must equal the square root of 2. And we are in meters. Meters. And so those would be our two answers. Okay, our height and our radius. Simple, simple, simple. Alright. Alright, the next one. We've got a cylinder that is inscribed in a cone. So what we have is, basically the idea is that we have this cone, okay, and inside of it we have a cylinder that fits inside of it. Okay, and so this is what it would kind of look like, kind of a rough sketch. And we know that the cone is 8 by 4, 8 high, 4 crossed. And so what we have to find is that we have to find what's the greatest volume that can be fit into this cone. What's the cylinder? And one thing we're going to have to do is find our constraint. Well, we know that the volume of a cone, or volume of a cylinder, is pi r squared h. Okay. In this case, we're going to deal with xy axis. So it's going to be v is equal to pi x squared y. Okay. Just, we're going to be using a coordinate plane, that's why. That's why. Now this cylinder that fits inside has to fit inside the length going down. This point here would be at 0, 8. This point here will be at 4, 0, okay, along your x and y. Well, what is that line? Well, that line segment is y equals negative 2x plus 8. right? And that's just finding that line segment. So we know that the height and the radius are going to fall within this constraint because it has to, the edge of the cylinder, the corner of it, has to be along this line somewhere, right? So now we take this y and plug it in to there. So we have v is equal to pi x squared times negative 2x plus 8. Multiply everything into it. We get v is equal to negative, let's see here, it'd be negative 2 pi x cubed plus 8 pi x squared. Okay. Take the derivative of it, drop the power. So that means v prime would be negative 6 pi x squared plus 16 pi x. Set it equal to 0. Okay, that's because again we want to optimize it, so after we take the derivative we set it equal to 0, getting us a 6 pi x squared is equal to 16 pi x. And then we're going to solve for x, which would be, well, one of them is 0 for sure. Okay, one of them is 0. So the x's kind of disappear. So we can divide both sides by 16 pi x. 16 pi x, getting us x is equal to 16 over 6, which can be reduced down to 8/3. So we know that our radius, or our x value right there, is 8/3. So now what would our y value have to be? Well, we take this 8/3 that we just found and we plug it into this x, and that's going to tell us the y. And so the y value would be y is equal to negative 2 times 8/3 plus 8, telling us a y value of 8/3. So we know our x and our y are 8/3. And we plug this, along with this, into our volume formula to find what v is. Pi 8/3 squared times 8/3, getting us our magical volume of about 512 pi all over 27 centimeters cubed. And there's our volume. All right. Easy breezy, right? Easy breezy. Easy breezy. All right, so moving on, this is number 6. And what we have is that we have a straight piece of wire that's 8 feet long, and it's bent to an L shape. What's the shortest possible distance from end to end? Okay, so x, y, and we're going to call the distance in between d, because, you know, I can, because I'm the one that's doing this problem. You guys could use any letters you want, a smiley face, a squiggly line, anything you want. Now, to find that distance, obviously, x squared plus y squared equals d squared. Okay. Now, what's our constraint that we have? So x and y, if you add x and y together, they must equal 8. Okay. They can't be smaller than that. They can't be larger than that. So we'll solve for y because, again, I choose to. You guys could solve for x if you want, but do whatever you want. And so now we're going to take this and we're going to plug it in there. And then we're going to have x squared plus 8 minus x. That whole thing squared is equal to d squared. Okay. So when we simplify it, we end up getting d squared is equal to 2x squared minus 16x plus 64. That's after distributing this through and simplifying everything from there. Okay. And yeah, so, you know, 8 times 8, 64, 8 times x, negative 8, 8 times negative x, negative 8, negative x times negative x, x squared. And then you add the x squared. So that's why. So d squared and basically d will have the exact same critical points. Okay, they just will. Because if you take the square root of it, we're still looking for when it's 0. So if we take the square root of the whole thing, we're still looking for when it's 0. And so what we'll do is that we'll just take the straight derivative of this. So d prime would be 4x minus 16, and solve for x as it's equal to 0, which means 4x equals 16, and we get x equals 4. So x equals 4, which means y has to be how long? 8 minus 4 is 4. 4 feet each. And now what would be the distance between the two? So what is d? That would be 4 squared 16 plus 4 squared 16, which equals square root of 32, which is 4 square root 2 feet. Ta-da! That was an easy one. Easy, easy, easy. Didn't even have to break a sweat on that one. Alright, let's look at the next one. So the next one, we've got the dimensions of a rectangle. We want to find what the dimensions of a rectangle is, the largest area possible. If we're on a coordinate plane, okay, one's length's along the x, the other one's on the y, basically cut in the middle, and then we have our parabola that we're constrained by. Okay, so the vertices have to be along this in some way. This y equals 9 minus x squared. And so what we have to do first is the area formula. A is equal to, it's going to be 2x, because x value here, and we've got two of them, so 2x times y. So 2xy would be our area. Now the constraint that we have is that y is equal to 9 minus x squared. Okay. So what do you think we're going to do? You got it. We're going to plug this into there, and for the y, which gets us 2x times 9 minus x squared. Hooray! Multiply everything through. We get 18x minus 2x cubed is equal to the area. And now what do? Well, we always take the derivative of it. Take the derivative of both sides, getting us an 18 minus 6x squared equals a prime. Set that equal to 0, so 0 that out. Let's use a different color. Blue's getting a little boring. And we solve for x, which gets us x squared is equal to approximately square root of 3. Yeah, plus or minus the square root 3, which, since we're on both sides, we can just say, well, x is square root 3. So if x is square root 3, that means this entire length is how much? Well, there's two of them. X squared 3 plus x squared 3 is 2x squared 3. Yay! Now we take one of these x squared 3's and we plug them into that x, because we got to find how high it is. What's our y value? And so when we plug it in, we get 9 minus 3, which is 6. So that means our y value is 6. So we have a 2 root 3 unit base with a 6 unit height. Now what is our total area of it? And our total area would be, let's see, 12 root 3. Just multiplying them together. Unit squared. So that is the largest area possible with this rectangle inside this parabola that we have. All right. Cool.